Okay, so this is the 2018 VCE Maths Methods Exam 1. I'm looking at question 1. So I'm going to start with question 1, part A. You can see it there just at the top of the screen. If y is equal to this, then find dy dx. So I'll just write that out so it's a little bit more explicit. I'm not sure how easily visible that question is. So that's y, and so we've got minus 3 times x cubed plus x squared minus 64 all cubed, and I want to find the derivative of that with respect to x. So this is a classic chain rule. We can basically set or let minus 3x cubed plus x squared minus 64 equals u, and then y becomes u cubed. And so when I want to differentiate y with respect to x, dy dx, which is the whole problem, of course, I can now do it as a chain rule problem. dy du multiplied by du dx. dy du is just the derivative of this with respect to u, so that's just 3u squared. 3, the power drops out the front, I take 1 off, 3u squared. And then I'm multiplying that by the derivative of u, which is the expression inside the bracket, with respect to x. So that's just going to be minus 9x squared plus 2x, and then the minus 64 is just a constant, so that disappears when we differentiate. And then the final thing is, of course, there was no u, so I'm going to bring back in place of this u squared what the original expression was. So it's going to be 3 times minus 3x cubed plus x squared minus 64 squared multiplied by this minus 9x squared plus 2x. Sorry, I'm getting a bit squeezed up there on the page. And that's it. The question's only worth 1 mark, and so I don't need to do anything else. We don't need to expand or anything else with that particular question. So that's 1 part A. Should have done that at the start, 1A. Let's take a look at 1B. So 1B, there we go. We've got f of x is equal to e to the x divided by cos x. Evaluate the derivative of that at that particular value of x, pi. So 1b, I'm differentiating, so my function is e to the x divided by cos of x. So this is a classic quotient rule problem. I'm not going to sort of write that out. That's on the formula sheet. But basically, if we are going to differentiate that, what's going to happen is I'm going to differentiate. So I'll have the lower part of the function, the denominator, multiplied by the derivative with respect to x of the top part, e to the x, minus the top part multiplied by the derivative with respect to x of the bottom part, cos x. And then the whole thing in the quotient rule is divided by the bottom part squared, so cos x all squared, which we'll often just write as cos squared x. So all I need to do is simplify that down a little bit. The derivative of e is just e. So I'll write that at the front. So that's e to the x multiplied by cos x. The derivative of cos x is negative sign, so that's going to combine with the negative here to become plus e to the x times sine of x. And then the whole thing is still divided by cos squared. Could simplify that, I suppose. We could take e to the x out as a common factor in the numerator. Probably, given that we don't really want this, we want the derivative at a particular value, so we want the derivative at pi, then we may as well just plug pi into this and see what happens. So I'm going to get e to the pi times cos of pi plus e to the pi times sine of pi divided by cos of pi squared, or cos squared pi. So then we just need to know, well, I mean, there's not much I can do about e to the pi. I can't simplify that. That's just going to be e to the pi. But we do know values for cos and sine. Basically, sine of pi is just 0, and cos of pi is -1. You can use just a simple sine and cos graph to sort of demonstrate that. I won't do that here. And so finally, if I substitute those into here, I'm going to get, just continuing this on down here, I'm going to get e to the pi times -1. So let's just make that minus e to the pi. I'm going to get e to the pi times 0. So that whole sine term is going to disappear. And then the whole thing is going to be divided by the cos term squared, so -1 squared. So that's just going to become 1. And so basically what I'm looking for is minus e to the pi. So the derivative, the value of the derivative at pi is minus e to the pi. And that's question 1.